See, suppose through the mathematics, suppose ABC, this is the triangle. So for this triangle, this is triangle ABC. For this triangle, generally we denote the vertices with capital letters ABC. Next, the length of the side opposite to capital A, we denote with small a by convention. Okay, so the length of the side AC, that is opposite to B, generally we denote with B. So this with C. Yes or no? Here A comma B comma C are vertices. Not only vertices, angles also we denote with capital letters. Vertices, angles denoted by capital letters. Vertices are angles. Next, ABC, small letters. Small ABC are lengths of the sides. Lengths of sides. These are the notations. So next point is, next few terms. So median. So median means, suppose in a triangle, suppose this is the triangle. In a triangle ABC, this is the triangle ABC. So median is the line joining the vertex with midpoint of opposite side. So the midpoint of BC is somewhere over here. Suppose the midpoint of BC is this one. So this BM distance is equal to MC distance. Then if you join the line A with this midpoint of opposite side BC, then this is called as a median. Yes or no? This is median. So definition is line joining vertex with midpoint of opposite side. So this is the median definition. Next, centroid. Next is centroid. Suppose so this is the triangle ABC. So the point of concurrency of medians is centroid. See, suppose in a plane, suppose two lines are meeting at a point. So this is called as point of intersection. Point of intersection. Suppose more than three lines are meeting at a point. This point is called as point of concurrency. So we can say point of intersection also, but generally we say point of concurrence. Yes, sir. If two lines are meeting at a point, this is point of intersection. More than 2 points, then this is called as point of concurrency. So here the definition is what, you know, the point of concurrency of medians is the centroid. See, suppose the midpoint of, what is the median? The midpoint, the vertex. If you join the vertex with midpoint of the opposite side, then that is called as a median. Therefore this is one median. So here the midpoint is somewhere over here. This is M2. So this is another median. Next, this is M3. So this is third median. So the point of concurrency is called as, this is called as centroid. So this is called as centroid. So no, this is the centroid. The point of concurrency of medians is centroid. Definition: point of concurrency of medians. is centroid. Next, and it is denoted by capital G. Centroid is generally denoted by capital letter G. So now G divides median in the ratio, that is centroid divides median in the ratio uh, 2:1, in the ratio 2:1. So 2:1 means here this is 2, this is 1. Yes or no? This AG is equal to 2, the GM is equal to 1, 2:1 ratio. That is AG over GM1 is equals to BG over GM2 is equals to CG over GM3 is equals to 2/1. So this is the centroid. Next term is orthocenter. Orthocenter definition is the point of concurrency of altitudes or heights is orthocenter. Suppose this is the triangle. Suppose this is the triangle. Yes, this is the triangle ABC. So altitude. So this is one altitude. This angle is 90 degrees. So this is another altitude. This angle is 90 degrees. So next one is, third one is, so this one here angle is 90 degrees. So the point of concurrency of altitudes is called as orthocenter. So generally orthocenter is denoted by capital H. Yes, sir. So definition I will write. The point of concurrency of altitudes is orthocenter. Capital H is the notation. So this is orthocenter. Next term is circumcenter. Circumcenter. So these we will use in straight lines frequently. That's why I'm giving the definition. Again, actually in detail about these centroid and orthocenter, circumcenter, and in detail you will learn in properties of triangle or solution of triangle chapter. So in this chapter, whatever the required, okay, that stuff only I am giving related to these terminology. Okay, I will not go in depth. I will teach in depth in properties of triangle, solution of triangle. So many relations and formulas are there. I will derive there. So next is circumcenter. Suppose this is the triangle. Now this is ABC. So circumcenter is the point of concurrency of perpendicular bisectors of sides. That is, this is the perpendicular and bisector is this one, the of side BC. Next perpendicular bisector of this AB side. So this one. Next perpendicular bisector of, it's a rough diagram, AC is this one. So this one is equal to this one. So this point, that is point of concurrency of perpendicular bisectors of side, is called as, this is called as circumcenter. Circumcenter. Generally circumcenter is denoted by capital O. So here the distance from the circumcenter to all the vertices are same. That is this distance and this distance and this, sorry, and this distance. These three distances are same. So what is the circumcenter means? If you can draw one circle, sorry, in circumcenter we can draw one circle which passes through the vertices of the triangle ABC. We can draw one circle which passes through the vertices of ABC. So here these three, what I said, these three distances from circumcenter to vertices, these three distances are same. Yes or no? These are same. So these are the radius of the circle. The circle is called as circumcircle because the circle circumscribes the triangle. Yes or no? The circle is circumscribe the triangle, or we can say reversely, the triangle is inscribed in a circle. Yes or no? Here circumcenter is this one. Why circumcenter? This is circumcircle. The center of the circle is the circumcenter. That's why. So these all distances are same. So this is the radius of the circumcircle. Generally, the radius of the circumcircle is denoted by capital R. This is circumcenter O. This is called as circumcircle. So this R is called as what? Circumradius. Radius of the circumcircle. Yes or no? So I will write the definition. A point of concurrency of perpendicular bisectors of sides is circumcenter. Yes or no? So here R is the circumradius. So you can write, you can say this R is circumradius, that is the distance of circumcenter from vertices. Distance of circumcenter from vertices. So this is circumcenter. Right. Now, next one is incenter. Next one is incenter. See, so this is the triangle ABC. Now, so the circle which lies inside the triangle, that is, it touches internally. So the circle touches internally. So for this is A, this one is B, this one is C. So here incenter means the circle, if you inscribe the circle in a triangle ABC, that is the circle touches the three sides of a triangle, then that circle is called as incircle. That center of the circle is called as incenter. That is one way of defining incenter. Another way is incenter is the point of concurrency of angular bisectors. The point of concurrency of angular bisectors. That is, the angular bisector. Actually, I will define first. I will not draw any circle. Yes or no? I will not draw any circle. Just I will take the triangle. I will take the triangle. Now, what is the definition? Without circle, I am defining this. Yes or no? The point of concurrency of angular bisectors is the circumcenter. So this is A. This one is B, C. The angular bisector of A is this one, and angular bisector of B means this angle is A by 2, This angle is A by 2. Next, angular bisector of B is this one. This is B by 2, B by 2. Next, angular bisector of C, C by 2, C by 2. So this point is, that is the point of concurrency of angular bisectors is called as incenter. So this is the incenter I. So here, if you inscribe a circle in this triangle, the diagram will be like this. This circle touches all the sides of the triangle. So in this one, the center of this circle is nothing but here incenter. Yes or no? If you draw a circle which touches all the sides, the center of this circle is nothing but the point of concurrency of angular bisectors. Yes or no? The point of concurrency of angular bisectors. So here, the distance from this incenter to the sides, all the sides are same. Yes or no? This is the incenter. So this distance and this distance and this distance, these all the distances are same. So we denote this all the distances with small r. This is called as in radius, because this is the radius of the inner circle. In previous one, capital R, that is the radius of the circumcircle. Capital R, circumcircle we denoted with radius is denoted by capital R. Here in radius is denoted by small r. So this is the incenter definition. So we will write the definition. Incenter is the point of concurrency of internal angular bisectors. Angular bisectors. Yes, sir. Internal angular bisectors. So next, in circle touches three sides. In circle touches three sides of a triangle. Three sides of a triangle internally. Three sides of a triangle internally. In circle touches three sides of a triangle internally. So next one is R is in radius. In radius. So it is distance from center. Like this. It is distance of center from sides. It is the distance of center from sides is in radius. So this is about incenter. Next point is, suppose this is the triangle, right? So this is the triangle ABC. Now suppose through A, suppose angular bisector, if you draw the angular bisector from A, that is, suppose this is the angular bisector of A. So that is, this is A by 2 and this one is also A by 2. So this is the angular bisector of A. So this angular bisector divides the opposite side in the ratio of adjacent sides. So just before we have seen, this side is denoted by small c and this side is denoted by small b. So here the statement is what? Here result is what? So angular bisector divides, that is here I will write the result. First here this, suppose this is some D. Now AB, result is AB is to AC is equals to BD is to DC is equals to C by B. This is the thing. So that is, so just a minute, particularly this one, right? Now from this one you can write like this: angular bisector divides opposite side in the ratio of adjacent sides. So no, this is the angular bisector. Angular bisector divides opposite side in the ratio of adjacent sides. So that is this D, this is the BD is to DC is equal to what? C is to B. Yes or no? This AB AC adjacent side ratio is same as this BD is to DC ratio, is C by B. That's why this D divides BC in the ratio of C is to B. This is the result.